Welcome back. So now we're going to look at a few problems with arrays, very simple problems. The rest of the problems, I'm going to make them available in your tutorials for the week. So let's look at this problem here. Write a program. Okay, let's start with this first problem here. 2 by 2 array, so that the last thing we learned can be put to use here. Write a program that reads in a 2 by 2 matrix. Again, remember what I told you. When it's a 2-dimensional array, customarily in linear algebra, we call those things matrices. Of any length, okay, meaning that the user has to specify the length, the rows and the columns, but it has to be 2 by 2 like a brick. From the console and adds these matrices together. So, first thing that comes to your mind is that you cannot make this 2 here because this is a 2 by 2 matrix. However, the dimension is already specified as 2 and 2. But the problem says of any length. So the first thing you would like to do is to read number of rows and number of columns from the user and put that as the dimension of your matrix. So enter number of rows, then end of line. Then I will just use a variable for that. I can call it n rows equals int.parse, whatever is entered on the console.readline. Then I'll just copy and paste these 2 rows for the number of columns. So enter number of columns, and I will use a variable called n columns. All right. Now I can go ahead and define. I can still use the same name for my matrix. But let's go back to the problem for a second. So we need to read 2 matrices. So I can call one A and I call the other one B. So for A, the number of rows will now be n rows, and the number of columns should be n columns. All right. And for B, all I have to do is to copy and paste this to specify the dimension of my second matrix. So I'll call my matrix B, and the same row and columns. Now it says that it has to be 2 by 2 matrix, but it doesn't say that maybe the number of rows must be the same as the number of columns. Sometimes you have that restriction because there's what you call a square matrix, and a square matrix, it has to be like a block. So if it's a 2 rows by 2 column or 3 rows by 3 column, it has to be in a block. Number of rows must be equal to number of columns, but in this case there's no restriction, so we're fine. So we have the 2 matrices. So now let's read into our matrix. I'm still going to use the structure that I used from the previous code. This structure we have right here. Just that in this case, I'm not going to initialize the matrix. I'm going to ask the user to type something into the matrix. So I'm just going to copy one of this because I'm doing something similar. I will say enter value for row. I'm going to use formatters here. Row that, column that. And in this case, my row, so my array will now go, my matrix is going to go row from 2 n rows. All right. Now, because the user might enter 4 rows, because there are 4 rows, and I know I'm starting from 0, so I would go to less than number of rows, because if you want 4 rows, then you're going to get 3. All right, because it's 0 indexed. And for my columns also, n calls here, and I'm going to make that modification as well. Everything looks okay on that side. Here I'm just going to say I, and I'm going to say J. All right. So when the user enters the value, I want to put it straight inside the matrix. So my name of my matrix for A, so let me first say matrix A. Enter that. Okay. So for matrix A of I, comma J, the value in that position now will be whatever the user enters at that time, which of course my int.parse will handle all of that. So I will just copy and paste this guy to read into the same space So let's say we're in row 1, column 1, row 0, column 0 for the two matrices. So we have to read in another value for the second matrix. The second matrix is matrix B. Row that works perfectly well. Then I'm going to have to change the matrix to B. Everything looks perfect. Now I can do this in one set of nested loops, and I have another separate set of nested loops to add the matrices together. Or I can just add them right inside this place at this time. So if I want to add the matrices together, I may want to put the result in another matrix that I call, C. All right, and that's my matrix C there. So before I leave this loop, I could say C of I comma j should be equal to A of I comma j plus B of I comma j. B I comma j. So that allows me to add the content of the first matrix in position I and j with the same similar position in the second matrix, because when you're adding two matrices together, you have to add item by item. So, and that's it. C is done. That's our matrix right there. It's ready. The addition of the matrices are done, but we haven't seen the matrix yet, so we have to display it. And in this case, I can just change the matrix to be displayed to C. It goes for the length of rows, n rows. It's less than, for obvious reasons. It goes to length of columns, n col. And each time it displays that, and at the end of the inner loop, it goes to the next line, as I've explained in previous videos. All right, so the exercise is done. Now let's see this matrix addition program in action. So in order to see what is happening, I'm going to just pop up my Microsoft Excel and show you another example in real time. So assuming that I'm looking at an example of 2 rows, 3 columns, all right? So a matrix that looks like this. -3, 4, 7, 1, 8, 19. All right, that's my matrix A. All right, let's say I have another matrix B here called 2, 1, 5, 6, 1, 0, 1. All right, so these two matrices, they have 2 rows, as you can see, but 3 columns. All right, so if you add them together, let's see what we're going to get before we run our program so we can compare our results. So you add the same position here to the same position here. -3 plus 2, that's -1. So I have -1 here. 4 plus 5, I've got 9 here. 7 plus 6, I have 13 here. 1 plus 1, I have 2 here. 8 plus 0, I have 8 here. And 19 plus 1, I have 20 here. So if I enter these two matrices, this is my matrix A here. Let me just color code it quickly. Okay, and that's my matrix B here. Another color. Then I'm going to get this answer here. All right, so let's try. Let's see our program in action. Here we go. So enter number of rows. We have 2 rows. 2. Enter number of columns. We have 3 columns. In this case, 3 columns. So it says enter value for row 0, 0. So that is row 0, column 0 for matrix A. That's -3. For the second matrix, so I'm just going to put this, the other stuff on my other screen so that I can see it. But you guys would be able to mount the screen if you need to. -3, matrix B, for that same position is 2. Matrix A, for the position after that, column 1, that's 4. And I have 5. And I have 7. And I have 6. Then I'm now on row 1. So I have 1. I have 1. I have 8. I have 0. I have I'm now on column 2. Okay, row 1, yes, still on row 1, column 2. I have 19 and I have 1. All right, so like I explained to you, it's done. So, and there is the sum. As you can see, minus 1, 9, 13, 2, 8, 20. It works perfectly fine. All right. So that's matrix addition in a nutshell. Matrix subtraction works exactly the same way. You subtract each item that corresponds to the other item, and that's it. So let's quickly look at the next problem before I end this video. Write a program that creates an array of 20 elements of the type of integer and initializes each of the elements with a value equal to the index of the element multiplied by 7. All right, so that's just a one-dimensional array. But let's quickly see how we can do that. What I'm going to do, I'm just going to comment out all of this as we normally do. That's gone. So I'll just pick some reusable code here. So there's the 20 elements, so we know the size of our array, so that's fine. So it's 20 elements, it's an array, it's one-dimensional. I give it any name I want. I can call it numbers. All right, equals new int, and the size is 20. That I know, and that's it. But I need now to initialize every position to the index multiplied by 7. So I'll just use one loop for that because it's a one-dimensional array. Copy something reusable here, put it here. Okay, so I have I equals 0, I is less than or equal to, I know it's 20, so less than 20, I plus plus, and for each position, my array is numbers, so numbers of position I should be equal to I multiplied by 7. That's what the problem says. And then it says display the array. So in displaying the array, I could just reuse this code block, and I could display the array inside that block again. So I could use this code block, and I could turn this to J, and to J. And in this case, I don't need to do this. I just need to display it, console dot write line. Right line. Yes, then I give it the array name and that index. And the job is done. So we're expecting a 20 index array. Now I'm displaying it on different lines. I'll just display it on the same line so that we don't have to scroll by just adding some more extra space here. And I can run it. As you can see, it works perfectly well. Position 0 is 0, 7, 14, and last position, which is position 19, times 7 is giving us that. All right, 133. All right, guys, so that's it for arrays, two-dimensional arrays, adding arrays together. In the next video, we will take a deeper dive at methods again and look at recursive methods, which are the kind of methods that would dominate our lab for the week. See you on the other side.